Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to see some of the very important topics for IIT JAM 2024 chemistry exam from Inorganic Chemistry. So let us start with the most simplest chapter, that is chemical bonding. So the most important topic from chemical bonding is what? Hybridization. ओके बहुत बार यहाँ से क्वेश्चन पूछे गए हैं. तुम कोई भी पेपर देख लो, एवरी ईयर देर इज 1-2 मार्क क्वेश्चन दैट इज फिक्स्ड. ओके, एक 2 मार्क का क्वेश्चन हमेशा इसमें से पूछते ही पूछते हैं. किसके ऊपर? या तो हाइब्रिडाइजेशन पूछेंगे, ओके, या तो तुम्हें इलेक्ट्रॉन ज्योमेट्री पूछेंगे, या तो शेप पूछेंगे, शेप या फिर मॉलिक्यूलर ज्योमेट्री. ठीक है, इन तीनों में से कोई भी एक टॉपिक पे तुम्हें हमेशा क्वेश्चन एक देखने मिलेगा 2 मार्क्स का. ठीक है, एंड ये बार भी आएगा. तो फर्स्ट ऑफ ऑल हाइब्रिडाइजेशन कैसे फाइंड आउट करते हैं. एक फॉर्मूला होता है हाइब्रिडाइजेशन कैलकुलेट करने के लिए. वो फॉर्मूला क्या होता है? हाफ इंटू नंबर ऑफ वैलेंस इलेक्ट्रॉन्स ऑफ सेंट्रल एटम प्लस नंबर ऑफ हैलोजेंस प्लस नंबर ऑफ हाइड्रोजन्स प्लस negative charges minus any positive charges if they are present. Okay, this is the formula for hybridization. How do you find out lone pair? Hybridization or steric number. How do you find out number of lone pair? Steric number minus side atoms. Okay, so so this is the chart that you have to remember, very important for molecular geometry. Okay, here what is given? Electron pair geometry is given. If the coordination number is 2, coordination number 2 है, 2 साइड एटम है, तो वो लीनियर होगा. एंड इसमें कोई भी लोन पेयर पॉसिबल नहीं है, राइट. अगर एक लोन पेयर आ जाएगा तो दूसरा सिर्फ मोनो डायटोमिक स्पीशीज बन जाएगा. ओके, सो लीनियर में कोई भी लोन पेयर नहीं होगा. ट्राइगोनल प्लेनर में there are 2 possibilities. One is all the 3 are side atoms, or if one is lone pair, 2 are side atoms, then it will be bent, or you can say angular. Okay, coordination number 4, electron geometry is tetrahedral and shape can be tetrahedral if all the 4 are side atoms. If one lone pair is present, trigonal bipyramidal like ammonia. If there are 2 lone pairs, just like water, okay, it will be bent shape. Okay, then we come to trigonal bipyramidal. There are if there is no lone pair, the geometry and the shape is same. Molecular geometry and electron pair geometry is same. That is trigonal bipyramidal. If there is one lone pair, it is sawhorse. Okay, or we can say this is seesaw shape. Okay, and if 2 lone pairs are present, it will be T shape, and 3 lone pairs are present, it will be linear. For example, I3 minus. Okay, it is linear having 3 lone pairs. Then octahedral, there are different possibilities. Octahedral, if all are side atoms, 0 lone pair, it will be octahedral. 1 lone pair, it will be square pyramidal. Okay, 2 lone pairs, it will be square planar. 3 lone pair, it will be T shape, and then 4 lone pair, it will be linear. So all these coordination numbers are fine. 2, 3, 4, 5, 6. Now most important what they are asking nowadays is they have started asking from coordination number 7 and coordination number 8. So this is which shape, if you can identify, this is coordination number 8. This was asked in some previous year question to 2021 or 20, I think 2021 paper or 22 it was asked. This is what? This is square anti-prism. Okay, I will provide the link in the description if you have not seen this video. XCF8 2 minus. Okay, this shape is square anti-prismatic or square anti-prism. Another coordination number 7. What is the shape of this? This is pentagonal. You can see this is what? 5-membered ring. This is pentagon. Okay, and then there is this pyramid. So one pyramid above, one pyramid below. So this is the shape of this is pentagonal bipyramidal. Okay, so this is what hybridization is, sp3d3. Okay, sp3d3. So in this, what type of question can be asked? Which all d orbitals are involved? Okay, there are total of 5 set of d orbitals, right? Which d orbitals are involved? Based on that, it can be either pentagonal bipyramidal, or there is another shape that is called dodecahedron. Okay, any one of this. So you must know कि कौन से d orbitals involved है hybridization में, वो पता होना चाहिए. Okay, so this was very important. Don't miss this topic of hybridization. Surely 2 mark question will definitely come based on shapes or geometry or hybridization. Next very important topic is coordination compounds. First, let us see the basic topics that are important. That is, from valence bond theory, you must know how to find out hybridization. In coordination number 4, it can be either tetrahedral, hybridization will be sp3, or it can be square planar, hybridization is dsp2. Okay, for this you must know the spectrochemical series. Okay, which ligand is strong field ligand, which ligand is weak field ligand, that all you must know. Some ligands you can remember. Okay, for example, Cn minus, carbonyl. Okay, En, these are what? These are strong field ligands. Okay, halogens, water halogens, these are what? These are weak field ligands. Okay, so you must know how to calculate hybridization. Now, coordination number 6, it can be either D2sp3 or sp3d2. That you must know how to calculate based on weak field or strong field ligands. Then what will be the geometry of this? Coordination number 6 is octahedral. Okay, then you must know how to calculate CFSE in octahedral complexes and tetrahedral complexes. Then factors affecting delta O. What is delta O? Crystal field splitting energy. Okay, this splitting energy is different from CFSE. This is what? This is crystal field stabilization energy. Okay, how do you calculate CFSE? This is many times this is asked in NAT. Very important. This is asked in NAT. Okay, there are 5 orbitals. For octahedral, I am telling you. Higher energy set is called EG. Lower energy set of orbitals, 3 orbitals, they are T2G. Okay, EGs, there are 2 orbitals, dz square, dx square, y square. These are along the axis. Right, and here there are dxy, dyz and dxz. Okay, ये तीनों कहाँ होते हैं? In between the axis. ठीक है, तो इसमें CFSE कैसे निकालते हैं वो आना चाहिए, एंड फैक्टर्स अफेक्टिंग क्रिस्टल फील्ड स्प्लिटिंग एनर्जी ये भी पता होने चाहिए. ठीक है, ये तो हो गया बेसिक टॉपिक्स, ये तो पढ़ना ही है, देयर इज नो ऑप्शन. देन यू मस्ट नो JTD. ओके, JTD, okay, this is hidden here, I'll write here. JTD, जॉन टेलर डिस्टॉर्शन, कौन से आयंस में होता है वो पता होना चाहिए. किस में होता है? जिसमें EG क्या होता है? अनसिमेट्रिकली फिल्ड. ठीक है, in orbitals where EG orbital is unsymmetrically filled, there strong John Taylor distortion is seen. For example, one having EG set of orbitals having 1 electron. Okay, symmetrically filled means this orbital also has 1 electron, this orbital has also 1 electron. This is symmetrical. Okay, for John Taylor distortion we want unsymmetrical. Unsymmetrical means suppose first orbital having 1 electron and second orbital having 0 electrons. This will be having slight JTD. Okay, weak JTD can be seen in this configuration. Now if I add 1 electron here, this will be symmetrical, no JTD. Then I add third electron, this will be strong JTD, very strong John Taylor distortion. Very strong John Taylor distortion. So the concept is that EG should be unsymmetrical. EG level should be unsymmetrically filled. Then you can see John Taylor distortion. Then you must know how to find out whether it is Z in complex or Z out complex. That is tetragonally compressed or tetragonally elongated. Elongated is called as Z out, and compressed system, tetragonally compressed system is Z in. Then we come on to advanced topics. Spinals, sometimes this is asked in JAM. Okay, very few times, but you can read this topic. This is a favorite topic of GATE. Okay, GATE and CSIR net exams. Okay, next is microstates. Very important. You must know how to find out microstates in free ion as well as in metal complexes. For free ion, what is the formula for microstates? Okay, it is same as that we calculate NCR, that is combination, permutation combination, same formula. Okay, n factorial divided by r factorial into n minus r factorial. How do you calculate? I will give you one example. Suppose I want to calculate for D3. Okay, D3, n is what? N is the maximum electrons that can be filled. Okay, this is for what? This is for free ion. Okay, I'm telling you for free ion. So n is the maximum electrons that can be filled. R is the electrons that are present. Okay, that is asked in the question. Electrons that are present. So here n value will be, D can have maximum of 10 electrons and R can have maximum of, R is what? It is a given electron, that is 3. So this will be 10 factorial divided by R is 3 factorial. So this will be 10 minus 3 factorial. So how do you solve this? 10 factorial divide by 3 factorial into 10 minus 3 is 7 factorial. So 10 factorial I can write it as 10 into 9 into 8 into 7 factorial. Okay, so 7 gets cancelled, 7 factorial gets cancelled. What is 3 factorial? 3 into 2 into 1. Okay, now solve this. 3 ones are 3 threes are 2 ones are 2 fours are. Okay, 4 threes are 12 into 10, 120. So for D3, there are how many microstates possible? 120. So these type of question can be asked in NAT section, NAT type of section. Okay, numerical answer type. So microstates for free ion you must know. You must also know for metal complex. Then ground state term symbol. You must know how to calculate the ground state term symbol. I will erase this first. Then we can see what is this ground, how to find out the ground state term symbol. That is very important, that you must know. Okay, what is this S? S is the total spin quantum number. Okay, total spin quantum number. L is the total orbital quantum number. Okay, and then J is what? Total angular momentum quantum number. Angular momentum quantum number. And always remember Sm, that is spin multiplicity, is 2s plus 1. Okay, so sometimes this is also written as Sm. Okay, then L and then J. So you must know how to calculate the value of total spin L and J. Then you can calculate the ground state term symbol. Okay, then another very important topic is magnetism. Magnetism, you must know how to calculate, find out whether a complex is paramagnetic or diamagnetic. Paramagnetic means it has unpaired electrons. Okay, diamagnetic means all the electrons are paired, no unpaired electrons. Okay, then there can be either only spin only magnetic moment. Mu is what? Mu is magnetic moment. It can be either spin only magnetic moment. Okay, formula is root of n into n plus 2. This is mostly seen in 3D series. Okay, d orbitals. Okay, mostly the elements present in d block. Okay, spin only magnetic moment. N is what? N is the number of unpaired electrons. N is the number of unpaired electrons. Then here we are not considering orbital contribution. Okay, the magnetism can be due to two motions. One is spin motion and another is the orbital motion. So if we don't consider orbital motion, this is the formula. SO means spin only. Okay, and LS means here coupling is taking place. Okay, there is spin orbital coupling. LS means spin orbital coupling. Then this is the formula. What is G? G is the Lance factor. Okay, how do you calculate Lance factor? For that also, this is the formula. Very important. G, how do you calculate? 3 by 2 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Remember, here there is the factor 2 that is present. Here there is no 2 that is present. So first you will calculate the value of G. Then you substitute this value of G in this formula, and then you can find out. So before that, what you must know is to calculate the value of S, L and J. Okay, this you can calculate, then you will get the value of G. Using the value of G, you will uh, calculate the magnetic moment for spin orbit coupling. Okay, so this is another very important and favorite topic of GATE and CSIR net exams, as well as JAM. Many times it is asked in IIT JAM exam as well. It can be asked in NAT type of section. Okay, NAT, NAT. They will give you some complex ion, and then they will tell you to find out the magnetic moment. Then you must know the meaning or the spin representations of ferromagnetic, antiferromagnetic and ferrimagnetic. This has not been asked many times, so this can be asked as a match the following in MCQ. Okay, match the following in MCQ section. And last very important topic from magnetism is orbital contribution of magnetic moment. You must know when orbital contribution will take place. What is a condition? That the T2G level should be unsymmetrically filled. Okay, remember not to get confused. When EG is unsymmetrically filled, what happens? JTD. Okay, that is a different concept. When does John-Taylor distortion takes place? When EG is unsymmetrically filled. Okay, if T2G is unsymmetrically filled, how T2G can be unsymmetrically filled? I'll show you. One case is this is unsymmetrically filled, this is also unsymmetrically filled. Okay, all the orbital having one electron, this is what? This is symmetrically filled means same electronic configuration in all the orbitals. Okay, so here there will be no orbital contribution of magnetic moment. Okay, this is the first case. Now if I start filling again, start pairing, this will again show orbital contribution. This will also show. This is now again symmetrically filled. Okay, so this will not show orbital contribution. Which all configuration will show orbital contribution? T2G1 will show, T2G2 will show, T2G3 will be symmetrically filled, that will not show. Then T2G4 will show, and T2G5 will show orbital contribution. These four configurations. Okay, so this was magnetism, and then some more important topics. So these are the favorite topics of GATE. Okay, if you want, if you have time, you can read this, or else you can leave this. But the next very important topic is trans effect. Okay, two times this has been asked. Okay, in previous year JAM paper, once it was asked in 2019, and then it was asked in, I think, 2020. Okay, two times it has been asked. Okay, this takes place in square planar complexes. Next, what you must know is how to draw Orgel diagrams. Okay, how to draw Orgel diagrams for ground state term symbol D and ground state term symbol F. What type of questions are asked? Energy levels. Okay, energy levels is asked. Or what is asked? Lowest energy ground term. Lowest energy, or we can say ground state term is asked. Okay, then next topic, important topic, is charge transfer. Which all type of charge transfer you must know? There are different types of charge transfer, right? One is metal to ligand charge transfer, then ligand to metal charge transfer, metal to metal charge transfer. Okay, all these you must know and their examples. Next very important topic is color. Okay, how do you identify color in complexes? What is the concept? Okay, here what we see is the complementary colors. We see the wavelength. Okay, if it is a strong field ligand, it absorbs it is higher, it has higher value of CFSE, right? So it will absorb the color of that particular wavelength, and a complementary color, okay, from the color wheel you can know from that complementary color will be the color of the complex. Okay, not the light or wavelength that it is absorbing, it will be the light complementary color that it emits. Okay, then what you must know is selection rule, spin selection rule, Laporte selection rule. What type of questions they can ask? They ask mostly the intensity of the complexes. Okay, they will give you a tetrahedral complex, octahedral complex. Then based on these selection rules, you have to determine the intensity of the complexes. Next very important chapter is organometallic compounds. Okay, organic coordination compounds, this many topics are enough. Then organometallic compounds, the most important, super important topic is 18 electron rule. Every year 18 electron rule is asked. And how, what type of questions are asked? Which complexes follows 18 electron rule? Which complex obeys 18 electron rule or opposite? Violates 18 electron rule. Any one of them they always ask. Okay, in both. JAM maximum times it is asked. In GATE also one question is fixed. Okay, so this was asked in JAM 2020, which many students did mistakes. If you count the total electrons, okay, count the total electrons, cobalt is atomic number 27, valence electrons are 7 plus 2 9, okay, 3d7 4s2, so 7 plus 2 9, so 9 2s are 18 plus 8 into carbonyl donates, one carbonyl ligand donates 2 electrons, so 2. So total if you count 9 2s are 18 plus 18 2s are, sorry, 8 2s are 16. This comes out to be 34. So many people what they marked is, the question was which of the following does not obey 18 electron rule. So many people marked this as the correct answer. This was option A, and this was incorrect. Why? Because you have to check the metal metal bond as well. Here there is one metal metal bond, so 34 plus this 2 electrons, so total it obeys 18 electron rule. The question was which does not obey 18 electron rule. So in this way it is very important, you must know how to count the total valence electrons. Okay, so 18 electron rule, many times they have asked question based on 18 electron rule. Next is metal carbonyls. So first topic is factors affecting the stretching frequency. Factors affecting the stretching frequency of the carbonyl. Okay, there are different factors that you must know. Then super important, very important, maximum times they have asked in all the exams. Okay, concept of back bonding. Okay, concept of back bonding in metal carbonyls. Okay, recently I had posted one video based on this topic. I'll provide the link, you can watch that if you don't know this concept. So there are 4 fixed questions. Either they will ask stretching frequency of carbon oxygen bond or bond length of carbon oxygen bond. They will give you a set of complexes, then they will tell you कि उसको अरेंज करो किसमें, कार्बन ऑक्सीजन स्ट्रेचिंग फ्रीक्वेंसी का ऑर्डर लगाओ या फिर कार्बन ऑक्सीजन बॉन्ड लेंथ का ऑर्डर बताओ. Okay, or other important thing is you must know whether it is metal carbon पूछा है या फिर कार्बन ऑक्सीजन का स्ट्रेचिंग फ्रीक्वेंसी पूछा है, and then bond length of metal carbon bond. Okay, so what exactly happens is, first step is this will donate, there will be formation of a sigma bond, and then there will be multiple carbonyl groups, right? So what will happen, the electron density which was donated to the vacant orbital of metal, what metal will do is, there is lot of electron density, so it back donates. Okay, so it back donates, and you can see the carbonyl oxygen triple bond has now become double bond. And so what happens, stretching frequency of metal carbon bond increases and stretching frequency of carbon oxygen bond decreases. And another thing you must know is bond order is what, inversely proportional to bond length. Okay, so bond order is increasing or stretching frequency is increasing, bond length will decrease. If stretching frequency is decreasing, then bond length will increase. Okay, so these questions are very, very important. They are asked many times. Then what is important is Wade rule. You must know how to count the total valence electron, and then you must be able to identify whether a complex is closo, nido, arachno. Okay, whether it is closo, nido, arachno, or hypo. Okay, mostly these three are asked. Okay, so there is one table that you must by heart. That based on this also I have made one video that I will share. I will put it in the description that you can watch. Then you must know how to calculate number of metal bonds, then different geometry of the clusters, metal clusters. Then you must know how to apply Wade rule in heteroboranes and Zintel ions. Okay, this is similar to what we do in boranes. Boranes means compounds having boron and hydrogen. Okay, for example, B2H6. Then you must know how to calculate STYX code. Normally it is not asked, but there can be question that they can ask from this. Then another very important topic is isolobal analogy. Okay, so next important topic in organometallic compounds is back bonding in metal carbenes. What is metal carbene? Okay, metal carbenes and then metal alkenes. And then metal nitrosyl, metal carbenes, metal alkenes and nitrosyl. Here also back bonding takes place in these complexes. You must know how that takes place, and again there will be either stretching frequency of carbon-carbon double bond or nitrogen-oxygen bond. Okay, this will be nitrosyl, this will be in alkenes and carbenes. Another last very important topic is reactions. There are four very important reactions of organometallic compounds that you must know: oxidative addition, reductive elimination, migratory insertion, beta hydride elimination. There what takes place? Agostic interaction. So what type of question they can ask? They will give you one reaction and they will tell you to identify which reaction has taken place. Which reaction has taken place, whether it is oxidative addition, reductive elimination, migratory insertion, or beta hydride elimination. Okay, so they will tell you to identify the type of reaction. Then another last important topic, second last important topic is catalysis. So first you must know what is turnover number. Okay, there is a formula to calculate the turnover number and TOF, turnover frequency. Okay, what is turnover number? Turnover number is moles of product divided by moles of catalyst. Then what is turnover frequency? Moles of product divided by moles of catalyst. And this is frequency, right? So it will be into time, divided by time. Okay, so sometimes what will happen is you will see that this moles of catalyst is not given directly. So how do you calculate moles of catalyst? Sorry, moles of product. Moles of product is not given. How do you calculate moles of product? Moles of reactant will be given and you have to multiply it by its percentage yield or efficiency. Okay, and very important, this should be in fraction 0 to 1. Now if the yield is, let's say, 50%, then you will not put here, you will not substitute 50, then you will not get the answer. 50% means 50 divided by 100. You will substitute 0.5. Okay, 0.5. If it is 60%, 0.6. If it is 75%, 0.75. Like this. Okay, it should be fractional. Okay, that is the only trick. Okay, they will give you moles of reactant, they will give you percent yield, and let's say they give you time, then they will tell you to find out turnover frequency or turnover number. Okay, 1 or 2 times it is asked in previous year question. Then some very important topics, that is hydrogenation. to convert alkene to alkane using a catalyst. This is what? This is RHPPH3 3Cl. What is the name of this? Wilkinson catalyst. Wilkinson's catalyst. Okay, some important reactions I'm telling you that you have to remember. Next is hydroformylation. Okay, hydroformylation means addition of hydrogen and carbonyl to alkene. Okay, addition of hydrogen and carbon monoxide. What will happen? What is the catalyst? This is the catalyst that is used. Okay, CO is cobalt. Okay, cobalt is a central atom, and this is the active catalyst. 1 or 2 times they have asked which is the active part. Okay, this is not the active part, this is the active part of the catalyst in hydroformylation. Next important topic is Wacker's oxidation. What happens in Wacker's oxidation? Alkene is converted to ketone. Okay, alkene is converted to ketone, and here two things are present. One is PDCl4. Question asked many times. What question is asked is which is the catalyst and which is the co-catalyst. So this is a catalyst, and CuCl2 is what? It is the co-catalyst or supporting catalyst. So this can be asked as a 1-mark question or in match the following. Next important topic is Monsanto acetic acid process and Tennessee Eastman acetic anhydride process. What is the difference between both this? Here what is present? Here we synthesize acetic acid CH3COOH, and here we synthesize acetic anhydride. Acetic anhydride is this. Okay, what is common between both these processes? Catalytic cycle, everything is common. The metal complex is also common. RH, carbonyl 2 and I2. Overall charge is minus. This is the complex that is used in Monsanto acetic acid process as well as Tennessee Eastman acetic anhydride process. Okay, so this was about the catalysis part, and the last important topic is bioinorganic chemistry. So 2 to 3 questions you can expect, that is 6 to 8 marks from bioinorganic chemistry. Now from this topic, it is a very small and most easy topic, but people try to ignore. So now they have started asking more questions from bioinorganic chemistry. So at least you can expect at least 4 to 6 mark questions from this, even more than that. First, you must know what is porphine, what is porphyrin. Then you must know what is a heme complex. What is heme? Meaning of heme is iron plus porphyrin. This complex is called as iron plus porphyrin is nothing but called as heme. It is present in hemoglobin. It is present in hemoglobin, oxyhemoglobin. You must know the structure of these hemoglobin. That is, it is also called as deoxyhemoglobin or hemoglobin, then oxyhemoglobin, then myoglobin. Okay, so yes, iron plus porphyrin, this is what? This is called as heme complex. Okay, sometimes question is asked, which of the following is a heme, contains heme as the core part of the enzyme, of the structure of that particular enzyme. Then you must know deoxyhemerythrin and oxyhemerythrin, hemocyanin, oxyhemocyanin. Okay, this is sometimes also called as deoxyhemocyanin. This is also called as deoxyhemerythrin. So that is a structure before interacting with the oxygen. So what you must know is structures of this. Okay, questions are asked based on structures, based on coordination number, magnetic nature, whether it is diamagnetic, paramagnetic, that is asked. And then what is asked mostly in bioinorganic chemistry is role of the enzyme, that is what is the role or function of the enzyme. And the most important part every year they ask is the metal, which metal is present. So in hemoglobin, which metal is present? In hemoglobin and myoglobin, it is iron. In hemerythrin, oxyhemerythrin, here also there is iron. In hemocyanin and oxyhemocyanin, there is copper that is present. Okay, then comes chlorophyll, or and in this, which is the core part of the structure, it is chlorine. Okay, base structure is chlorine, and here which metal is present? Mg2 plus. Okay, we know magnesium is present in the green leaves. Okay, in the structure of chlorophyll. If you see the structure of chlorophyll, you will find magnesium. Then vitamin B12 and coenzyme B12, which metal is present? Cobalt. Cobalt 2 plus is present. And what is the difference? In vitamin B12 there is one CH2 or methylene bridge that is missing. Okay, otherwise the structure of the base ring here, it is what? Okay, you don't have to get confused. In chlorophyll it is chlorine. Okay, chlorophyll, chlorine, that way you can remember. And in vitamin B12 and coenzyme B12 it is corine. CORRIN, corine. Okay, these names you have to remember, they can ask these names. Then super important, maximum times questions are asked from this, that is carbonic anhydrase. You must know the mechanism. Then which metal is present? Zinc is present in carbonic, in this mechanism of hydration of carbon dioxide. So what exactly happens is water is added to carbon dioxide. Okay, and what you get is H2CO3. This is a reversible reaction. What is H2CO3? Carbonic acid is formed. Okay, here which metal is present? Zinc. Along with this carbonic anhydrase, another important enzyme is asked, that is carboxypeptidase. There also which metal is present? Zinc. Okay, peptidase. Ase means to break, peptid means it will break what? It will break peptide bonds. It is used in amino acid, breaking of the peptide bonds in polypeptides. Okay, in polypeptides, if you want to break the break any particular bond, break the peptide bond. What is a peptide bond? It is amide linkage. Okay, if you want to break this bond, you can use this enzyme carboxypeptidase. Here also zinc is present as a central metal. Metal ion is zinc. Okay, so this was the last topic. So all these topics if you cover, I am sure you will get a very good rank, and you don't have to miss any of these topics. These are the important topics I have given you. Okay, there is so much content that is available, but based on the syllabus of IIT JAM and the previous year questions that are asked, based on that I've given you all these topics. So these are super important. You cannot miss any one of the topics from the list of topics that I've given. So I hope this has helped you, and thank you.